Torque-to-yield fasteners require a different tightening method. When a bolt stretches within the elastic limit, it will return to its original size. Stretching the bolt just past the elastic limit allows it to provide maximum clamping force, but will not return to the length it was originally. The area just past the elastic limit is called the yield point. This is where torque-to-yield fasteners are tightened to. Gasket compression, dirt, friction, torque wrench calibration, and surface quality are factors that reduce the accuracy of torque measurement. The torque-to-yield method overcomes these factors because each bolt provides the same load. In addition to a torque specification, torque-to-yield bolts are tightened a specified number of degrees. A 90-degree specification means the bolt must be tightened 1/4 turn. The reason this method is possible is that torque-to-yield bolts are precision fasteners. Turning the bolts the same amount allows them to stretch equally. This places the bolts in yield and allows the bolt loads to be consistent. Torque-to-yield fasteners allow smaller bolts to do the same work that larger bolts used to do. The use of smaller bolts allows for smaller component size and weight. This helps in the design of lighter engines. Torque-to-yield bolts must be replaced after one use. They are tightened past their elastic limit and will not provide proper clamping force when tightened a second time. The method for tightening torque-to-yield bolts is similar to the torque wrench method. The bolts are tightened in 2 or 3 steps in a specific torque sequence. An example of the torque-to-yield method is the cylinder head bolts on the 4.6-liter engine. A torque wrench is used for the first step of this method. The bolts are tightened to specification in sequence. The last 2 steps are performed without the torque wrench. The second step requires rotating the bolts 90 degrees in sequence. The last step requires tightening the bolts an additional 90 degrees in sequence. It is normal for the wrench to feel mushy or soft near the end of the second 90-degree rotation. Unlike the torque wrench method, if the wrench stops during torque to yield, it does not affect the tightness of the bolts. The 4.6-liter engine also uses these bolts for the connecting rod and main bearing caps. In hard-to-reach areas, the use of scribe lines helps to ensure the right amount of bolt rotation. After the first torque step, scribe lines on the surface at the 0, 90, and 180-degree points. Scribe a line on the bolt head even with the 0-degree line. The second step now requires aligning the bolt head and the 90-degree lines. The third step requires aligning the bolt head and 180-degree lines.